Guys, so you all are warmly welcome back to my YouTube channel. So guys, my YouTube channel is SL Learners, and I think this is the fourth video of my YouTube channel. And last week only I got 1k subscribers, so thank you if you have subscribed my YouTube channel. And so guys, today this is the first video, and I'm going to upload after getting 1k subscribers. So today I'm going to teach you. I thought about teaching you about maths. So I love maths, and I think maths is a funny subject, and maths give a lot of things to my life. And so guys, let's go to our video. So today I'm going to teach about maths, as I told you. So I think this symmetry lesson will be very important for you. And so before telling that, symmetry is our first lesson in maths, and other symmetry will be a very interesting subject lesson for you, because it's all about like cutting and pasting and drawing and etc., which will be very useful for you, and it will be a very nice lesson. Without talking much, let's go to our video. So guys, 1.1 is known as bilateral symmetry. I think that you have learned this at school. So bilateral symmetry, a figure of a quadrilateral shaped card is given here. By folding this figure along the dotted line, we obtain two parts that coincide on each other. So, if you're talking about bilateral symmetry, it's like the things that if we for something, if they are like coincide, that is known as bilateral symmetry. A figure of a quadrilateral shaped card is given here. As I think that you can see a shape of a square, that's a quadrilateral. Quadrilateral is a shape which the all the four sides, there are four sides, and there are for all the four sides are like they should be there won't be any spaces, like with they should make with four straight lines. Quadrilateral shaped card is given here, that's the square. By folding this figure along the dotted line, we obtain two parts that coincide on each other. So, if you're talking about this, there are two, we can obtain like over here, we can obtain two parts, this first one, and this is the second one, and both of them are coincide on each other. And I think that you have sometimes you might have done this at school. So just take a piece of paper and fold it on each other, and you can get two parts which are coincide on each other. And over here you can see a dotted line, and the dotted line is the dotted line is from the place which you um, fold the square. Okay, let's go. So here you can see a few figures having two parts which coincide with each other when folded along the dotted line are shown below. Here you can see a butterfly and a dog and an ant, or an insect. So the a few figures having two parts which coincide with each other when folded along the dotted line are shown below. As I can see, you can see here a butterfly, and you can see that if you fold the butterfly along the dotted line, you can get two pieces which are coincide. And the dog is also same. If you take the picture of the dog, and you can, if you fold it along, if you fold it along the dotted line, and I think you can get two pieces which are coincide. And as the same for the insect, if you like take the image, and if you just take a printout and try to do this, just take the picture of the insect, and you can just uh, fold it along the dotted line, and you can get two pieces which are definitely they will be coincide. uh, Many objects in the environment have the property that they can be divided into two equal parts. Most creations do have this property. Let us learn more about plane figures and laminas which have this property. So guys, in here, many objects in the environment have the property that they can be divided into two equal parts. Most creations do have this property. Let us learn more about plane figures and laminas which have this property. So guys, let's go to the next slide and learn about more plane figures and laminas which have this property. This is no the property is which the coin the if you fold it along the coin side you will get if you fold it along the dotted line you will get two coincide things. So over here you can see four pictures in figure 1, figure 2, figure 3 and figure 4. In figure 1 there is only one line that divides the figure into two equal parts which coincide. However, each of the figure 2, 3 and 4 has more than one line that divides the figure into two parts which coincide. So, in figure 1 there is only one line that divides the figure into two equal parts. I think guys you can see that in figure 1 there is only one dotted line, but in figure 2, 3 and 4, in figure 2 you can see two dotted lines, in figure 3 you can see three dotted lines, and in figure 4 you can see it's a circle and it is we can count and it we can count the dotted lines at that, but they have given only four dotted lines. Uh, that is over here. So guys, activity 1, we are moving on to the activity 1. So step 1, trace this figure onto a paper and cut along the border of the figure. So guys, as it is like here, just take a figure like it's like a I can't like a cylinder or yeah no like a test tube. That's in figure 1. So just take an image of that and cut it along the border of the picture. Fold the figure so that you get two equal parts which coincide as shown in the figure 2. In figure 2 you can see there are only one part, but there are two parts which are coincide, so that's why you can't see the part. Step 3, draw a dotted line along the fold. Now paste the figure in your exercise book. And now just take it and again keep it like figure 1 so you can see the like the folded um, and the fold, and you can draw a dotted line over there and then you should paste it in your exercise book. That's the in the first lesson, that's the first activity that we should do. If a plane figure can be folded along a straight line so that you get two equal parts which coincide, then that plane figure is defined as a bilateral symmetric plane figure. The line of folding is defined as an axis of symmetry of the figure. In the above activity, you must have drawn the dotted line shown in the figure as the line along the fold. This line is an axis of symmetry of the figure. This bilateral symmetric figure has only one axis of symmetry. So you can see like a picture over there, and we have done this in activity 1. So guys, you can just see a picture of this, and it is known as um, uh, if a plane figure can be folded along a straight line, so you get two equal parts which are coincide. I told you that if a figure is folded along the dotted line, if that figure get two parts, which, like two parts definitely, like they can't be like sometimes they are going you can sometimes if you get something like the wires or something you can get coincide, you should get coincide parts which coincide, then that plane figure is defined as a bilateral symmetric plane figure. If those two figures are like coincide, then that figure is defined as a bilateral symmetric plane figure. So the line of folding is defined as an axis of symmetry of the figure. So guys, here you can see the axis of symmetry of this figure, and there are dotted lines to show you the axis of symmetry of this figure. So that is known as the axis of symmetry. In a bilateral symmetric figure, the two parts on either side of an axis of symmetry are of the same shape and of the same area. The figure depicts a rectangle with a dotted line drawn across it. This line divides the rectangle into two equal parts. However, if we fold the rectangle along the dotted line, the two parts will not coincide. Therefore, this line is not an axis of symmetry of the figure. A line through a plane figure which divides it into two parts of the same shape and of the same area which do not coincide with each other is not an axis of symmetry of the figure. So guys, I think that you learned something over here because you understood something over here. Okay, and in this figure you can see axis of symmetry. No, just dotted line is going, and if you take a piece of paper and cut it to a rectangle and check whether this is coincide, you can get which that is not a bilateral symmetric plane figure because the two parts will not be coincide. Therefore, this line is not the axis of symmetry of the figure. So, a line through a plane figure which divides it into two parts of the same shape and of the same area which do not coincide with each other is not an axis of symmetry of the figure. So, in here also you can identify that this is not an axis of this plane figure. Okay, let's move on. So 1.2, drawing axis of symmetry. So guys, this is our second activity and there are 4 steps and let's see what should we do. So step 1, copy the figure given below in a piece of paper and cut out each lamina. Step 2, find a bilateral symmetric figure from the figures that were cut out. Step 3. Draw all the axes of symmetry of the figures with bilateral symmetry. Step 4. Paste all the figures having axes of symmetry in your exercise book. Near each figure, write its number of axes of symmetry. So guys, I think this is not much important for you. This is just the exercise activity. So copy this frame figure copy the figures given below on a piece of paper and cut out each lamina. So you should just first you should copy the figures given below and cut it off in a piece of paper and you should check in as step 2 you should check whether you should like just fold and check whether these laminas are the figures with bilateral symmetry. And as step 4, you should paste all these pictures in your exercise book and write how many, just like how many axes of symmetry with each figure content near it. I think that you understand to it. So let's go to our next slide. So in this one, from the following, choose the bilaterally symmetric figures with a correctly drawn axis of symmetry and write down the corresponding letters. So guys, in A, I think that you can see it's like coincide and bilateral symmetric figure, because as the dotted line is like straight and both, as if you even see it, you can like choose whether it is bilateral, that you can like guess even that is a bilateral symmetric figure. And guys, B is a rectangle, so even that is an bilateral symmetric plane figure. And C is also a bilateral symmetric plane figure. I think that you can see two triangles like there. So this is not a bilateral symmetric plane figure, as I see that. I think that you can see that there aren't any bilateral symmetric figures, and the dotted line is not going in the correct bilateral symmetric place. So it is not an bilateral symmetric figure, because as we all see, E is the dotted line of E is going like horizontally, and it is going to the wrong direction. If it goes straightly, it will definitely be a bilateral symmetric figure, but now it is not. So if is not a bilateral symmetric figure, as you all can see that if is not a bilateral symmetric figure. So G is a bilateral symmetric figure. If you fold it down and if you check it, you can see that D is a bilateral symmetric figure. And thus H is also a bilateral symmetric figure. So because two parts will be definitely coincide, because it is you can see that the two parts will be definitely coincide. Like if you see it at the first time, even you can guess that the two parts will be definitely coincide. And guys, I is not a bilateral symmetric plane figure, because the tail of the reef is the point of the reef is not it should be like a heart, and that's why it is not a bilateral symmetric figure. And guys, J is a binary symmetric figure. That's a oval circle, and there the the uh, the axis of symmetry is going down at horizontally, or you can see it. And K is also binary symmetric plane figure, you can see it. And because two parts will be definitely coincide. And L is also an binary symmetric plane figure, and you can see that if you take a piece of paper and cut like L, and you just do it, and so your like practical knowledge will be like it will be improved. So guys, I think that you learn something from over here, because it will be very useful for the other lesson. And this is the exercise 1.1 also. Let's go to the second. And the second part is cut out laminas of the following shapes using a tissue paper. Draw all the axes of symmetry of each of them. II. Paste all the figures having axes of symmetry in your exercise book. So guys, there is a half of a circle something, and a rhombus, and a hexagon, and something like a moon. And over here they are telling you you should like cut them, and you should with a tissue paper, and you should draw all the axes of symmetries and paste it in your exercise book. So in the first one, the half the circle, you can see like one axis of symmetry, and in the rhombus you can see only one axis of symmetry, and in the hexagon, yeah, I think it's a hexagon, yeah, it's a hexagon, and over here you can see six axes of symmetries, and in the half of the moon you can see just one axis of symmetry. These are the axis of symmetries of this. And second one, paste all the figures having access of symmetry in your exercise book. So guys, you should paste this in your exercise book. So third one, first one, Cut laminas of the following shapes using a paper. Draw all the axes of symmetry of each of them. First one, A, rectangular shape. B, triangular shape with two sides of equal length. So you can see the A is a rectangular shape, and they are so I have here put here the second one. Write the number of axes of symmetry of in each of the above figures. They have two axes of symmetries, and B has this one axis of symmetry. And the third one, create another symmetry figure by joining two figures of the shape given in A and B above the paste in your exercise book. So if you make this, the B should come onto the A, and that makes like a house. I think you can understand because that just made I could prepare it, and B should come upon A, and there should be like a house, and the half of them goes to a bilateral symmetric figure. So yeah, first you should cut these things, and then you should find how many bilateral symmetric figures, and A has two and B has just one. It's the middle one, and the third one you should like join them and make a house, and you should paste it in your exercise book. So the last one, write the statements above in your exercise book. Mark a tick in front of the correct sentences and a cross in front of the incorrect ones. The first one, in a bilateral symmetric figure, the two parts on either side of an axis of symmetry are equal in shape and in area. I think that you all know that as I taught you, that statement is an correct statement. Because in a bilateral symmetric figure, the two parts on either side of an axis of symmetry are equal in shape and in area. So the second one, there are bilateral symmetric figures having more than one axis of symmetry. Yeah, it is very easy for you. There are bilateral symmetric figures having more than one axis of symmetry. That is truly correct. And the third one, the number of axes of symmetry in a circular lamina is greater than the number of axes of symmetry in a square. That is also correct, because the number of axes of symmetry in a circular lamina is greater than the number of axes of symmetries in a square. How many axes of symmetries are there in a square? There are only two axes of symmetries in a square, but there are you can't even count the axes of symmetries in a circular lamina. Then the statement should be correct. Fourth one, the maximum number of axes of symmetry in a bilateral symmetric figure is 1. That is wrong, because there can be more than one axis of symmetry in a bilateral symmetric figure. The fifth one, if a bilateral symmetric figure which has at least two axes of symmetry is cut along one axis and divided into two equal parts, then each of these two parts too will be bilateral symmetry. Just again listen. If a bilateral symmetric figure which has at least two axes of symmetry. So guys, just take a square. It is cut along one axis and divided into two equal parts. Just cut it along one axis and divide it into two equal parts. Then each of these parts too will be bilateral symmetry. Yeah, that's true, because the statement is true, because just take a bilateral symmetry. You can take like a square and then make two bilateral symmetric the axis of symmetries, and then cut it along the middle, and then you take one part and you can again cut it, and then you can get two parts. Then check whether these two parts are coincide. If they are coincide, that they will definitely be coincide. So that means it is a bilateral symmetry. That's correct. The statement is true. So the first one is true. The second one, in a bilateral symmetric figure, the two parts on either side of an axis of symmetry are equal in shape and in area. That's true. The second one, there are bilateral symmetric figures having more than one axis of symmetry. That's also true. The number of axes of symmetries in a circular lamina is greater than the number of axes of symmetry in a square. That is also true. The maximum number of axes of symmetry in a bilateral symmetric figure is 1. I told you that it is false. And fifth one, if a bilateral symmetric figure which has at least two axes of symmetry is cut along one axis and divided into two equal parts, then each of these two parts will be bilaterally symmetric. That is also true. So guys, let's move on to the next slide. So 1.3, creating plane figures having bilateral symmetry. So this is the third activity in our textbook. So step 1, get a piece of paper of any shape and a pair of scissors. You should take a piece of paper and any shape. Just get a piece of paper with any shape and a pair of scissors. And then fold the paper into two. Draw any figure on your choice such as it contains a part of a line of folding and is limited to the area where the two portions overlap. See diagram. You can see this diagram as that. Step 4. Cut out the figure you drew. Unfold the figure. At the end of the above activity, you obtain a bilateral symmetric figure. Its axis of symmetry is the initial line along which you folded the paper. So guys, this is like an easy one. So you can just get a piece of any paper, like any paper which you like, 3 rows, any paper, because you don't like to waste papers. And then get a pair of scissors and then fold the paper into two pieces, and so draw any figure on your choice, such as, yeah, you can draw like a fish, or like a, just you can draw circle or square or rectangle or anything you can draw, but that should be limit folding, and it should be limited to the area where the two portions overlap. So step 4, cut out the figure you drew, and I told you to draw just a half of a circle, so you can get a full circle, and then unfold the figure. You can get a figure which is bilateral symmetry. So in step 4, the textbook took a piece of a vase, and that in the step 3 they drew a vase, the half of a vase, and they cut it, and then they unfold it, then they got the axis of symmetry, and they got the axis of symmetry, and in step 4 they got the half of the picture. So at the end of the above activity, you obtain a bilateral symmetric figure. Its axis of symmetry is the initial line along which you folded the paper. So at the end of the above activity, you obtain a bilateral symmetric figure. That means you, as I told you, in step 5, after you unfold the figure, you got a bilateral symmetric figure. Its axis of symmetry is the initial line along which you folded the paper. As in step 1, in step 2, we folded the figure in the line which we folded the figure is the axis of symmetry in the initial line along which you folded the paper. That in step 5 we got the vase, so the ball. So in that one there was an axis of symmetry. That axis of symmetry is the thing which we folded in step 2. Okay, let's go to the other slide. Activity 4. Step 1, step 2, step 3. In activity 4 there are only 3 steps. So step 1, take another piece of paper and fold it twice so that you obtain a right angle corner. So just take a piece of paper and fold it twice that you obtain a right angle corner. Now draw a figure on this paper so that it includes the right angled corner as such that it is limited to the region where the four portions of paper overlap. Cut the figure and unfold it. You will obtain a bilateral symmetric figure with two axes of symmetry, where the axes of symmetry are the two lines along which you folded the paper. Sorry. Step 3. Cut out their symmetric figures in this manner. Step 3. Cut out their symmetric figure in this manner. You can see the picture in step 3. As I told you, step 1, take another piece of paper and fold it twice so that you obtain a right angle corner. Just take a piece of paper from your books or from anywhere. A wastage paper it is also okay. So take a paper and fold it twice, 1 and 2. Then you will get a corner which is like very sharp. Then you should obtain a right angle corner. Now draw a figure on this paper so that it includes the right angled corner and such that it is limited to the region where the four portions of paper overlap. Cut the figure and unfold it. You will obtain a bilateral symmetric figure with two axes of symmetry, where the axes of symmetry are the two lines along which you folded the paper. That means that you can now cut any shape. So you will get like two axes of symmetries. Those two axes of symmetries are sorry the places where you folded this. In step 3, it is also the same thing which is in step 2 that you have understood activity 4. So let's go to the next page. So over here you can see activity 5. Step 1, step 2, step 3, step 4, step 5 and step 6 also. So step 1, get a paper and some paint. Step 2, fold the paper into two parts. Step 3, now unfold the paper on the side that it is folded in. Place a drop of paint so that it lies on the line of folding. Step 4. Now fold the paper back and press with your hand. Step 5. Unfold the paper. At the end of this activity, you will obtain a bilateral symmetric figure as in the given diagram. Step 6. Following the above steps, obtain different bilateral symmetric figures by changing the amount of pen used or by pressing down in different directions. So, in step paint in the symmetric line, in the axis of symmetry. And step 4, just unfold fold the paper and press with your hand. Just press fast with your hand. So you will get see you will see that the figure after unfolding it, you will see a bilateral symmetric figure has been drawn in your paper. And assignment: create various bilateral symmetric plane figures by cutting out folded paper as well as by placing drops of paints on folded paper as done in the previous activities. Prepare an attractive wall decoration using the symmetric figures that you created. In this assignment, create various bilateral symmetric plane figures by cutting out folded paper as well as by placing drops of paints on folded papers as done in the previous activity. This is in this assignment, letting you just do the things that we did in activity 5. You should put some just fold it and put some paint on it and put it again, and then you can from that you can like you can get some different shapes which are bilateral symmetric. So prepare an attractive wall decoration using the symmetric figures that you created. You can create more than 5, 6, 7, 8, and you can create 50 or something. Then you can make it you can create an attractive wall decoration using the symmetric figures that you have created and you have that. It's good. So let's go to the next one. So, 1.4, drawing bilateral symmetric plane figures. Let us consider the symmetric plane figure given below, which has been drawn on a square ruled paper. The axis of symmetry of this figure is the vertical line indicated by the dotted line. The points at which the straight line segments of a linear plane figure meet are defined as the vertices of the plane figure. Usually, the vertices are named using capital letters of the English alphabet. Second point, the vertices A, B, C, and D are on the right side of the axis of symmetry of the figure. Let us consider when the points A, B, C, and D are located on the left side of the axis of symmetry. The point A is located at a distance from the axis of symmetry which is equal to the distance from A to the axis of symmetry on a horizontal line which passes through A. A is defined as the vertex corresponding to A. Line which passes through A. A is defined as the vertex corresponding to A. Similarly, B with a comma, C with a comma, and D with a comma are defined as the vertices corresponding to B and C and D respectively. Let us consider how a bilateral symmetric figure is drawn on a square ruled paper or grid by identifying corresponding vertices. So, in 1.4, let us consider the symmetric plane figures given below, which has been drawn on a square ruled paper. Here you can see as this is your just imagine that as this is your exercise book. Just look at this picture. You can see in the right hand this is like a pot, and in the center you can see the axis of symmetry. On the right hand you can see D, C, B and A. On the left hand you can see D with the comma on the top, C with the comma on the top, B with the comma on the top, and A with the comma on the top. And in the first the point, they tell that the vertical line indicated by the dotted line, the points at which the straight line segments of a linear plane figure meet are defined as vertices. That means that you can see D to D, there is a point at D. The name of the point is D, and there you can see a vertices of the plane figure. Usually the vertices are named using capital letters of the English alphabet. Yeah, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices over here, and all 8 have been named in English letters. The vertices A, B, C and D are on the right side of the axis of symmetry. Let us consider when the points A with the comma on the top, B with the comma on the top, C with the comma on the top, and D on the comma on the top are located on the left side of the axis of symmetry. The point A is located at a distance from the axis of symmetry, which is equal to the distance from A to the axis of symmetry on a horizontal line which passes through A. A with the comma on the top is defined as the vertex corresponding to A. Line which passes through A with the comma is defined as the vertex corresponding to A. Similarly, BC, B with the comma, C with the comma and D with the comma are defined as the vertices corresponding to B. B, C and D respectively. So here you can see the D with the comma is like it is directing the corresponding letter is D, and C with the comma the corresponding letter is C. B with the comma the corresponding letter is B. A with the comma the corresponding letter is A. Let us consider how a bilateral symmetric figure is drawn on a square ruled paper by identifying corresponding vertices. Let's go to the next slide. Activity 6. Step 1. There are, in this one, you can see 6 steps. Step 1. As indicated in the figure, select a vertical line on the grid and mark it with a dotted line. Step 2. Select 3 points of intersections of vertices and horizontal lines on the grid which lie on the left side of the dotted line. Name these points as A, B and C respectively. Join the points A and B and the points B and C using straight line segments. On the right side of the dotted line, mark on the grid the points corresponding to the above points named A with a comma on the top, B with a comma on the top and C with a comma on the top. Join the points A with the comma on the top and B with the comma on the top and the points B with the comma on the top and C with the comma on the top using straight line segments. Step 5. Join the points A and A with the comma on the top and the points C and C with the comma on the top using straight line segments. So if I'm going to explain this, in step 1 you should just select a vertical line and mark it with a dotted line. You can just keep a dotted line in any place where that you like in your exercise book. You should keep it in the middle, not in the corners. In step 2, you can select 3 points and put A, B and C as marked in this book. And then you can match A and B and C. And then on the other side corresponding to A, put on on the A with a comma on the top, and corresponding to B, put B with a comma on the top, and corresponding to C, put a C with a comma on the top on the right side. And then match A with a comma on the top with B with a comma on the top, and B with a comma on the top with C in the comma on the top. And then again match A with A and A with a comma on the top, and at last match C and C with a comma on the top. Then this image will be successful. So example 1. Complete the bilateral symmetric figure such as the dotted line in the diagram is its axis of symmetry. The distance from A and B to the axis of symmetry is equal to the length of 3 squares. Therefore, let us mark the points A and B such that the distance from it to the axis of symmetry is also equal to the length of 3 squares. By similarly marking the point C with a comma on the top and D with a comma on the top such that the distance from C with a comma on the top to the axis of symmetry is equal to the length of 6 squares, and the distance from D with a comma on the top to the axis of symmetry is equal to the length of 4 squares as shown in the figure. And joining the points as indicated, we obtain a bilateral symmetric figure. So, in this is example number 1. You can see, you can just keep a dotted line in the as key as in this diagram, and you can keep the as in this diagram, and you can 1 2 3 4, you can after 4 dots you can keep a dot and mark the point as D. It is a vertex. And then going down 6 squares, you can keep a point as C. It is the second vertex over here. And then again coming to the left, after 3 squares, mark a point and mark a vertex and name it as B. Then again coming down, after 3 squares coming down, mark the point as A. Then again make A to the, then take again A to the axis of symmetry. So then we should make this as the second picture. How to make it? Then you should take 4 dotted lines from the axis of symmetry to the left side, and then mark the place and keep the mark the place as B with the comma on the top. And then again coming down 6 squares from the B place, after coming down 6 squares and going 2 squares left, keep the point C with the comma and mark it. This is the second vertex of the left side. And then after coming 3 sides to the right, mark the point again as B with a comma on the top, and that is the third vertex of left side. And again coming down to 3 squares, keep a point over there and name it as A with a comma on the top. And then at last you should connect the two. You should connect A with a comma on the top to the axis of symmetry. and then you can make a house. This is the I explained you in the easiest way and the short form of the whole paragraph. And this at last we obtain a bilateral symmetric plane figure. So let's move on. So guys, let's move on to exercise 1.2. And the first one, this is a very easy exercise for you to do. And the first one, copy figure A in your square rule exercise book. Second one, the dotted ink indicates the axis of symmetry. Place a mirror on this line and observe the bilateral symmetric figure. 3. Draw the complete of bilateral symmetric figure. 4. Repeat the above step from figure B and complete the bilateral symmetric figure. So, you should, in figure A, you should make the other part in figure A. Just take one up and then goes one to the left side and again come back down and go to the right side and again go up near it and again come down to the and then you can make an M and M and in figure B and you should make a T. There is a T and you should make another T. Then just go 2 squares down and go to 2 squares left and go 1 square down and go 5 squares to the right and go 1 square to up and again go 2 squares to left and again go 2 squares to up. Then you can make the figure B. And so let's go to the second one. Draw a bilateral symmetric figure with the points marked as vertices and identify its axis of symmetry. I have done that to you, and I think that I can make draw it nicely in this place, in this with this thing. So it is not very ugly. So just there are they have drawn 4 dots. From the left side, go to the up one, and from the up one, go to the right side one. Then from the right side one, go to the one the left the one which is very near to the right side, and again go to the one which is from that one go to the one which is very near to the left side, and from there go to the left side, and let's go to the third one. Copy each of the figures given below in your exercise book. Complete the figures so that you obtain a bilaterally symmetric figure in each case. 1, 2, 3, 4, 5. So, you should copy the figures given below in the exercise book and complete the figures, and that means you should draw another figure like this, and you should do it. And the fourth one, place each of the figures given below on a tissue paper and copy them in your exercise book. So you should just now turn the tissue paper in the dotted line, draw the other half of each of the figures to obtain bilateral symmetric figures. That means guys, you should just um, draw them in a bilateral in a tissue paper and fold it into two and draw it, and you can copy them in your exercise book, and you can do it at home for like homework. For the other half of the exercise 1.2. Fifth one, first one. Draw 3 bilaterally symmetric figures on a square ruled paper such that each figure has only one axis of symmetry. So guys, in this one, there no, let's like discuss both. Draw the axis of symmetry of each of the above figures. So guys, let's in the first one, they draw three bilaterally symmetric figures on a square ruled paper such that each figure has only just one axis of symmetry. That means only all the figures should have only one axis of symmetry. That means you can take a triangle which only two sides are equal, and that means that has only one axis of symmetry. And you can take what this you can take a picture of a picture of a butterfly, and you can take a picture of a dog. So they have only one axis of symmetry. So you can mark the axis of symmetry of them in each of the above figures. So let's go to the sixth one. Draw two bilateral symmetric figures on a square ruled paper such that each figure has only two axes of symmetry. Draw the axis of symmetry of each figure. So guys, in the sixth one, that says draw two bilateral symmetric figures on a square ruled paper such as that each figure has only two axes of symmetry. That means guys, you can just take a square and a rectangle. So they have only two axes of symmetries, because in the square the horizontal one and the vertical one, in the rectangle the horizontal one and the vertical one. Draw the axis of symmetry of each figure. That is all. So we have came to the end of this lesson, and now we are going to the summary. If a plane figure is divided into two equal parts which coincide with each other when folded along a particular line, then that figure is defined as a bilateral symmetric figure. The line of folding described above is an axis of symmetry of the figure. So guys, over here I will read you once again. If a plane figure is divided into two equal parts which coincide with each other when folded along a particular line, then that figure is defined as a bilateral symmetric figure. The line of folding described above is an axis of symmetric of the figure. I will read you once again because this is the thing which is very important in this lesson. The summary is the most important thing in any lesson. If a plane figure is divided into two equal parts which coincide with each other when folded along a particular line, then that figure is defined as a bilateral symmetric figure. That means if um, two that means if a plane figure is divided into two equal parts which coincide with each other when folded along a particular line, then that figure is defined as a bilateral. Yeah, we learned in the lesson that if a plane figure is particularly divided into two parts, and the two if the two parts are coincide to each other, that means that figure is a bilateral symmetric plane figure. So the second point, the line of folding described above is an axis of symmetry of the figure. That means, guys, like the the bend and the bend of the line is known as the axis of symmetry of the figure. So guys, this is the end of the video. So thank you so much for watching this video, and if you watch till the end, that means that's very good. So guys, if you haven't subscribed my YouTube channel yet, please like this video if you like. this video, and uh, please, please put a comment on this video. How should I improve and what should I do next? And please put a comment what subject should I teach you next event. So guys, if you haven't subscribed my channel, please subscribe it now. So please subscribe it and watch my other videos also. Thank you.